Here we have our first problem. Examine the given statement, then express the null hypothesis, h sub 0, and the alternative hypothesis, h sub 1, in symbolic form. Our statement is the mean weight of women who won a beauty pageant is equal to 115 pounds. Now your null hypothesis, h sub 0, is a statement that the value of any population parameter such as proportion, mean, or standard deviation, stuff like that, is equal to some claimed value. An alternative hypothesis is simply a statement that makes that null statement untrue. So here we have the mean weight of women. This U symbol here is the symbol for mean. So our answer is obvious. Our null statement is our mean is equal to 115. Our alternative statement is a statement that makes that untrue. So our alternate hypothesis is your mean is not 115. And we are ready for our next problem. Number 2. Examine the given statement, then express the null hypothesis, h sub 0, and the alternative hypothesis, h sub 1, just like we did in problem 1. Our statement is high school teachers have incomes with a standard deviation that is more than $22,000. We are asked to express a null parameter equal to some value, so we know that our h sub 0 is going to be $22,000. We are asked to express our standard deviation as more than 22,000, so the alternative hypothesis, h sub 1, has to be that our standard deviation is greater than 22,000. So, obvious answer is obvious. Problem number 3. Exactly the same thing. Examine the given statement and express our null and alternative hypotheses. Our statement is more than 29% of internet users pay bills online. Which of the following hypothesis tests to be conducted? Well, P is your symbol for population. As we know, we have to set it equal to something, so our population is equal to 29%. It's also saying that more than 29% of internet users pay their bill online, so our alternative hypothesis is P is greater than 29%. And again, obvious answer is obvious. Number 4. State the final conclusion in simple, non-technical terms, which in statistics is a very oxymoronic statement. Our original claim is that the proportion of male golfers is less than 0.7, and our initial conclusion is to reject the null hypothesis. Now when you reject the null hypothesis, you're rejecting it because there's evidence to support the alternative. And when you fail to reject it, there's not sufficient evidence to support the alternative. So here we have our our original of being equal to 0.7. Now our alternative is that the proportion of male golfers is less than 0.7. So we're going to fail to reject this. So there it is. There is sufficient evidence to support the claim that the proportion of male golfers is less than 0.7. And there you go. And here we move to number 5. When 109,857 arrests for federal offenses were randomly selected, it was found that 32,442 of them were drug offenses. When testing the claim that more than 29% of federal crimes were for drug offenses, the accompanying calculator display was obtained. Use the results from the display to test the given claim at a 0.05 level of significance. Now your level of significance is alpha. And if your p value is larger than alpha, there is not sufficient evidence to support your claim. If your p value is less than alpha, there is sufficient evidence to support your claim. Now here your p value is exponentially lower than your alpha, so there is sufficient evidence to support the claim. Now be careful not to confuse your p value with p hat or the p of a population number, and you're good to go to move on. And number 6. Trials in an experiment with polygraph include 96 results, which is your sample size. That include 22 cases of wrong results and 74 cases of correct results, which will be your number of successes. Use a 0.05 significance level, which is alpha, to test the claim that such polygraph results are correct less than 80% of the time. Now this will be your claim, also known as your alternate hypothesis. Based on results, should polygraph evidence be prohibited in trials? And then it's just going to ask you to include your null hypothesis, etc., etc. So when you come over to Statdisk, you're going to come to Analysis, Hypothesis, and Proportion of one sample. You're going to click your your alternative, which is number 6, that your proportion is less than the claim proportion. Just plug in your values, which we already spoke about, and hit Evaluate. Your answers will be here, and be really careful with your rounding. Of course, Compass is pretty picky. As you see here, Statdisk is also rather accurate on whether to fail to reject and whether it has enough evidence or it doesn't. You're going to plug that here into the paragraph. Now, depending on your specific question, these answers here, do not appear and should be prohibited, will vary. Just use your better judgment and common sense on how to fill those in. And let's move on to number 7. Number 7, a survey of 61,647 people included several questions about office relationships. Of the respondents, 25.2 reported that bosses scream at employees. Use a 0.05 significance level to test the claim that more than 1/4 of people say that bosses scream at their employees. This will be your alternate. How is the conclusion affected after learning that the survey is an online survey in which internet users choose whether to respond? Long drawn out problem, but quick and dirty solution. As with everything else, firstly come up with your null and alternate. The problem asks you to test the claim that more than 1/4 of people, which will be p greater than, say that bosses scream at their employees, so your probability is 0.25, the decimal equivalent of 1/4. Therefore, your null is p0.25 and your alternate is p greater than 0.25. The logic on these hypotheses should start to be more intuitive to you at this point. So using the same window in Statdisk of the hypothesis test, proportion one sample, we're going to use number 5, which, as you can see, population proportion greater than claim proportion. The significance level is given, claim proportion is 0.25, sample size is 61,647, and your number of successes is derived from taking 25.2% of the total sample population given to you. Now, for this number of successes, you need to round to the nearest whole number. You can't have 15,535 and 0.04 hundredths of a person, so just round to 15,535. Just follow Statdisk instructions on failing to reject the null. There isn't enough evidence, so if the sample is voluntary, the conclusion might not be valid. This is the last part, and it's just common sense because it's a voluntary sample, and no voluntary sample is valid regardless of the calculations. So just plug in your values, answer your questions down here, and move on to number 8. Number 8. In order to monitor the ecological health of a particular region, various measurements are recorded at different times. The bottom temperatures are recorded, and the mean of 30.323 degrees Celsius is obtained for 61 temperatures recorded on 61 different days. Assuming that the standard deviation of 1.7 degrees Celsius, test the claim that the population mean is greater than 30 degrees Celsius. Use a 0.05 significance level and the displayed results. Well, as we know from our previous examples, if p is greater than alpha, not sufficient evidence. If p is less than alpha, there is sufficient evidence. So our claim is our alternative hypothesis. And as you see here, our alternative is greater than 30 degrees Celsius. Since p is greater than alpha, there is not sufficient evidence to support the claim. So basically, we're rejecting our h1 and accepting h0. So if we use our stats lingo, we are failing to reject the null hypothesis, and there is not sufficient evidence to support the claim. Moving right along.